Hi everyone, welcome back to the Data Guy, your go-to channel for mastering data engineering tools and concepts. If you are new here, I am Vishal and I create videos to help you build a strong foundation in data engineering tools and concepts. In today's video, I am going to share 5 practical tips to boost the performance of your Azure Databricks workloads. Whether you are a data engineer, a data scientist, or just starting out, these tips will save you time, money, and headaches. So stay tuned and don't forget to hit the like button and subscribe for more data engineering content. So let's start with today's agenda. We will look into cluster optimization, efficient use of storage, partitioning best practices, Z ordering and data skew, and collaborative development. So let's start with cluster optimization. Azure Databricks offers multiple cluster configurations. The key here is to choose the right cluster size and settings for your workload. Cluster optimization in Azure Databricks is a crucial part of improving performance, reducing cost, and maximizing resource utilization for your workloads. Now, let me break it down step by step conceptually so that you can fully understand it. First, what is cluster in Azure Databricks? So basically, a cluster is a set of compute resources like virtual machines configured to execute your workloads, such as running notebooks, jobs, or streaming data. Now, cluster in Azure Databricks can be interactive clusters, which are used for ad hoc analysis or development. It can be job clusters, which are dedicated to running scheduled or automated jobs, or it can be automated clusters, which are created by jobs and terminated automatically after the job ends. Now, why the cluster optimization is important? So, basically, cluster optimization helps you in reducing the cost to avoid provisioning resources or keeping idle clusters running. It improves the performance. It ensures efficient resource usage to speed up the job execution. It handles scalability. It dynamically adjusts resources based on workload demands. Now let's have a look at key concepts in cluster optimization. First up is cluster sizing. In a database cluster, there are two main types of nodes, driver nodes and worker nodes. The driver node is the brain of the cluster. It handles task coordination, like assigning and monitoring jobs. Meanwhile, the worker nodes are the muscle. They execute this task in parallel. Cluster mode. Azure Databricks gives you three different modes, each tailored to specific use cases. First one is standard mode. This is your go-to for most workloads. It's reliable and great for general purpose use. Next one is high concurrency mode. If you have multiple users running short, frequent queries, says with BI tools like Power BI, this mode is optimized for that. It's built to handle high throughput efficiently. And next one is single node mode. This mode is perfect for lightweight development, debugging, or testing when you don't need distributed computing. It's simple and fast for small tasks. Autoscaling. Let's talk about autoscaling. One of the most powerful features of Azure Databricks for efficient resource management. Autoscaling uses dynamic resource allocation to automatically adjust the number of worker nodes based on the workload. It scales up, adding more workers when the workload increases, and it scales down, removing workers when the cluster is idle, saving your money. Now, to make the most of autoscaling, you will need to configure two parameters, that is, minimum workers and maximum workers. Set minimum workers. Set this to ensure you always have enough workers to handle your baseline workload. And maximum workers, you can set an upper limit to control cost and prevent over provisioning. Autoscaling is ideal for dynamic workloads as it ensures you are only paying for the resources you actually need. Now, when creating cluster in Azure Database, you choose node types based on Azure virtual machine sizes. So we have different nodes here, standard nodes, memory optimized nodes, compute optimized nodes, and storage optimized nodes. Standard nodes are general purpose virtual machines. For example, standard D4S V3, which have balanced CPU, memory, and disk performance. Next one is memory optimized nodes. So basically, these are memory intensive virtual machines. These are ideal for workloads requiring high memory, for example, caching or for large data sets. Compute optimized nodes. These are CPU intensive VMs. It is suitable for high performance computing and real time analytics. Next one is storage optimized nodes. These are storage focused virtual machines, which are recommended for high disk input-output workloads. Now let's have a look at cost optimization techniques. Cost optimization techniques, in this we have spot instances, auto termination, and cluster pools. So spot instances, use spot VMs for worker nodes to reduce cost by up to 90%. Spot VMs in Azure are low cost virtual machines that lets you use Azure's unused compute capacity at a huge discount, up to 90% cheaper than regular VMs. However, they come with a catch. They can be evicted anytime if Azure needs the capacity for another user. So spot VMs are ideal for fault tolerant workloads, but avoid them for critical jobs as they can be interrupted. Next one is auto termination. Enable auto termination to shut down clusters automatically when ideal for a specified duration. With auto termination, cluster will shut down automatically after being idle for a specified duration. This ensures you are not paying for unused resources. And next one is cluster pools. Cluster pools allow you to pre-provision resources, which means the infrastructure is already available when you need it. This drastically reduces the startup time for clusters, making them available faster. Next one is monitoring and troubleshooting. Ganglia is your go-to tool for monitoring resource usage. It provides detailed metrics on CPU, memory, and network usage, helping you identify performance bottlenecks at a high level. On the other hand, the Spark UI is ideal for tracking the performance of individual jobs and tasks. You can drill down into stages, tasks, and job execution details. Keep an eye out for red flags like skip partitions or long task execution times. This often points to areas that need optimization. Next up is logs. Logs are invaluable when troubleshooting issues. You can analyze driver and executor logs to debug specific problems. To make things easier, configure your cluster to deliver logs to Azure Blob Storage or ADLS, Azure Data Lake Storage. This gives you a centralized place to store and review logs, making it easier to perform detailed analysis and identify the root cause of errors. Last one is observability. For a broader view of your Databricks environment, leverage Azure Monitor. Azure Monitor provides end-to-end observability, offering insights into query execution performance, cluster utilization trends, potential issues across your pipeline. With this level of observability, you can proactively address problems and ensure your clusters are running smoothly. Now, there are some best practices for cluster optimization. Choose the right VM type for your workload. Enable autoscaling to handle variable workloads. Set auto termination to avoid paying for idle cluster. Monitor and analyze Spark UI to identify bottlenecks. Use job cluster for production ETL pipelines to save cost. Leverage Delta Lake for efficient data storage and processing. So, cluster optimization in Azure Databricks is about balancing performance and cost. By configuring the right cluster size, type, autoscaling setting, and leveraging tools like Delta Lake and Spot VM, you can achieve efficient resource utilization. Additionally, monitoring tools like the Spark UI and the Azure Monitor plays a critical role in ensuring your clusters are performing as expected. Thanks for watching. If you found this video helpful, give it a thumbs up, subscribe to the Data Guy for more beginner-friendly data engineering content, and share this video with someone who is just starting out. Have questions or ideas for future videos? Drop them in the comments below. I would love to hear from you. Until next time, happy coding.